Hello everybody. This video should help to get you acquainted with the Java Scanner class, a class that is used for getting input from various places. It will be required in order for you to complete the CS211 Labs, Lab 02 involving the treasure map. So this will be the first in two videos. This one will explore Scanner briefly, and the next one will explore the classes that come along with that Lab 02 pack. So one of the classes that comes in the pack is the scanner demo, which demonstrates the basics of how to get input from various places in Java. The scanner is not a class that is included by default for the compiler. It's not visible to it. But it does live in the Java standard library. You just have to direct the compiler to import it. That's to say, the scanner lives in the Java util package, and it is called scanner. So please make it available to my class for use in order to do stuff. We'll also be reading files using a scanner, reading data from files using the scanner. So we'll need the file class from the java.io package. Make sure to include that as well. Things can go wrong when you're getting input, particularly from files. You can ask for files that don't exist, for instance. And Java requires in a lot of cases that if you do something that is potentially dangerous, where something could go wrong, that you admit it. This is the notion of declaring the main method can actually throw some sort of an exception. Now there are specific kinds of exceptions associated with input, but for the moment I'm going to be lazy and just say I could throw some kind of exception. All of the exceptions that could come up in the input are actually derived from exceptions, so saying it's possible that an exception could occur covers those. We'll talk a lot more about inheritance and exceptions as we go forward in class. You can take this one as an article of faith that you'll need this in order to appease the compiler. Alright, so down here is where things start to get interesting. We actually grab ourselves a scanner, and the declaration of I will have a scanner, and it will be named input, should be fairly familiar. It fits the same pattern as I would like a string called S, or I would like a double called D. Capital for a reference type, as in scanner is a class. Then over in here, you should recognize new scanner as invoking a constructor to build a scanner. Interestingly, we'll pass an argument into that scanner. It's the system.in object. You guys should be well acquainted with system.out right now, which is used to produce output to the terminal with the print lines and the printfs and the whatnot there. System.in is the counterpart to that deals with input from the system terminal. So declaring that you are going to build a scanner and its argument is system.in tells the scanner to read from that source, the system.in source, which is going to be read from user input that's typed directly into the terminal. So the sort of common thing to do when you want input is to ask, to print some sort of a prompt, which we'll do in the next line, to say system.out.print, and I want an integer, so I'll inform the user input an integer. And in the next sort of action line, we'll say I'm going to have an int I. I'm going to get it by parsing input from the user. This will be calling the input, which is a scanner, calling its method nextInt, which reads whatever text the user has typed in after they hit enter, and try to create an integer out of it. This is a notion of converting whatever string characters they've typed in, like 1, 2, 3, into the binary integer 1, 2, 3, and then shuffling that into the box of storage where I lives. So let me compile and get this show sort of started running. We'll have a data file in a minute that's not compiled, so this looks like everything was okay. I'll go ahead and run, and lo and behold, I get that prompt that I wanted to print out. Input an integer, and this box is Dr. Java's smart way of saying I'm waiting for input from the user. Please type something here. So I'll type 1, 2, 3 as my integer, and then I'll hit enter, and it looks like everything went okay. Next thing to show up is input a real, which is the next prompt that's over here. Real numbers, again, are numbers that have fractional parts, and the type double is what Java uses for those kinds of numbers. And corresponding to that is a scanner method called nextDouble, which allows us to grab doubles from input just like we did for integers. So I'll type another fine number in, this time fractional, 4, 5, 6, 7. which is a very nice looking double. So that seemed to succeed okay. We won't know for sure for another second when we print things, some sort of result out. But for the moment, we'll ask then for a string. This one is slightly tricky to remember. The scanner method to read a single string is just next. And again, this is a sort of failing, in my opinion, on Java's part of making things uniform. I would expect next string instead is just next. So try to remember that one. Importantly, strings and other things, according to Scanner, are separated by spaces by default. So if I were to type something like hello world in, the string that would be read would just be the first one, the hello part of this, as the space would indicate the next, the token is ended. So for the moment, I'll just leave hello in the input string right now, which should be fine, and we'll read hello right here. If I had typed hello world, only the hello would have been read there. So after I hit enter, this final string should go into its corresponding string variable s, and we'll do some printing then to print out the I, which we read up here, the D, which we read here, and the S that we read here. And hopefully that should read 1, 2, 3, and then 4.56, and then hello. Cool. Okay, so it looks like all went well. Here's my 1, 2, 3, 4.56, and hello, and a whole bunch of other stuff, which we'll deal with in just a minute. So getting input from the user using a scanner is pretty straightforward. Make yourself a scanner that reads from system.in, and then use the methods like nextInt, nextDouble, and next to get respectively integers, doubles, and strings. So the other common place that you'll want to read data from is from files stored on hard disk somewhere. These can be quite large or very small. We'll deal with a very small data file for this exercise. It's called data.txt. It's included in the homework or in the lab pack, and it's comprised of 4 lines with semi-interesting stuff on it. At the top there's an A-string, exclamation mark, a few numbers, another string, and a few more lines of all strings. In order to get in order to get Scanner to read from a file, you'll need to build the scanner in a slightly different way. Instead of passing in system.in as the source of stuff to read from, you have to pass in a new file, and the file is an actual class here in Java. That's why we did our import java.io.file up here. So down here is my new file, and files as a constructor take an argument, which can be a string that names a file. And since we'll be running in the same directory as data.txt, we won't need to include any sort of path and look in the current directory for that data file. So this will build a file, which is an object, and then pass it into the constructor for Scanner. And the scanner will recognize, oh, this is a file, and start reading from that file instead of reading from the user input from the terminal. So invoke the same sets of methods, and this is very nice. You don't need to learn a new set of methods to read from files. They're the same. Next reads a string from the file. NextInt reads an integer from that file, and nextDouble will read a real number from the file. And finally, we'll add another string to be read from the file. And if you look carefully at data.txt, that's a string, an integer, a real number, and another string. That's the whole first line of text. So once I read those things in, I'll print them out. Notice here the use of printf instead of printline. I'm a big fan of printf for its ability to format output, for instance, to say I only want 3 decimal places of accuracy for this real number. So here's, we should be printing SID and S2, which if we read from data.txt properly, A-string exclamation mark will be the first string, 22, 0.988, since we're rounding up to 3 decimal digits of accuracy, and B-string, ... Alright, so this looks good. Let me compile and run just to make sure that we're looking good. I have to re-input stuff here. So down here is where we're printing out what we read from the file, and this looks pretty good. A-string was read first, then 22, then that number, but rounded to 3 decimal digits of accuracy, and B-string. So it looks good. When you're reading from files and you're done, it's a very good practice to close whatever input you're working on. This frees up operating system resources, and it is possible if you keep opening files and never closing them that you'll exhaust some of the internal resources of the operating system. So always after reading from files and you're done, in this case we just wanted the first line, close that input. And when you want to reset back to the beginning of a file, the easiest way to do this with scanners and input files is just to recreate the scanner, which will move the reading position for our input way back to the beginning of the file. So this will, in effect, reset back to the beginning of the file and start reading from the beginning again, reading that first line. It's very common to want to loop through an entire file, really, perhaps searching for something or reading all of the input and converting it to some internal representation. That will be part of your lab assignment. So here is a loop that will do that. It uses the scanner method hasNext, which asks the scanner, is there anything left to read in whatever source I'm reading from? There will almost always be something left to read in the system.in, the terminal output, but files do have finite capacity, so they'll run out eventually. So while this is true, while there is more stuff to read, we use yet another new method from the scanner class. That is the nextLine method, which instead of reading just a single string, will read all the way to the end of a line based on the new line delimiter of the operating system. So that will be returned as a single string, and all we're doing here is printing out what was on a particular line. It was this whole line, incrementing I as we go along. So we'll get output that should be like line 1 was blah, line 2 was blah, line 3 was blah, and finally close the file when there's nothing left to read. Looking down at the input, you can see line 1 was A string and this other stuff. Line 2 was line number 2, line number 3, all done now. That looks to be exactly what was in data.txt, so all is well. So that's a crash course on Scanner. Lets you read from a variety of different sources, and if you look carefully at the Java doc, you'll find you can read from other places too. Perhaps network locations, certainly read from strings as a source of input, but the most common will be to read from the terminal, from the user, or to read from files. A variety of methods that let you grab various things and do parsing on them. Next, we'll just grab a string for your general input. Next int, next double, we'll grab numbers of various types. A quick note, if you try and read something that can't be interpreted as an integer, you will get an error of some kind. So if I run this guy again, and the first thing I'm asking for is an integer, and write something in like hello, the scanner will be very unhappy with me. Input mismatch exception. So keep in mind, parse things carefully. Make sure you're reading input files in the correct format. And when we get to that point, you'll probably want to catch errors, catch exceptions as input is being read. That's good practice. Look for another video in a few moments on the classes that are included along with the treasure map.